Okay, so we're going to review everything that we talked about and learned before the break on circles. And this is the content that's going to be on your quiz. So I'm going to make 3 videos on these sections. So for this video, we're going to talk about the definition of a circle, the arc length, and area of a sector. Okay, so let's start. So your circle, what is the definition of a circle? So back to those guided notes that we did in the beginning of the unit. The circle is the set of all points in a plane equidistant from a point called the center. So meaning, this is your center. All the points right here, from one point to the center, this distance will be the same thing if I chose this point going to that center. It's going to be the same distance. And that, by the way, will be your radius for extra information. So this is your definition. Now we're going to talk about arc length. There's 2 methods of how to find the arc length. So I'm going to show you method 1 and method 2, and you decide whichever one you prefer. So for number 1, we're going to determine the arc length. Round to the nearest tenth. Okay, so over here we're going to find the arc length. So the arc length is right here. We're looking for this arc length. So this will be method 1. Method 1 is a visual of proportions and actually shows you how the equation gets derived for the second method. So for here, to find the arc length, so I'm looking for arc length. This little arc length, it's part of the whole circumference. So it's your arc length over circumference. And it's equal to your central angle. Your central angle is when the vertex is at that center point. So this is your central angle. So it'll be your central angle. So this little angle is 72 degrees. It's a little section out of the whole circle, and a whole circle is 360 degrees. Okay, and now we just plug in our values. So we're looking for arc length. So I know what that is. Now, to find the circumference, the formula is 2 pi r equals my central angle, which I'm going to write this as theta. This is not 0. This represents, think of it as a variable specified for an angle. So this is theta. It's your angle over 360 degrees. So now we're going to go ahead and plug in our values. Our radius is from the center point to a point on the circle, so that'll be 7. So we have arc length over 2 pi times my radius, which was 7, equals my central angle, which was 72 degrees, over 360. So now we're going to go ahead and multiply this across. If you want to make it nicer, you do 2 times 7 and just leave it as 14 pi if you want. You could always do that before you cross multiply. So you have 360 times your arc length equals my circumference was 2 pi times 7 times that central angle, which is 72. So now let's go ahead and multiply here. So we have 360 times the arc length, which is what I'm trying to find, equals, and we're going to do 2 times pi. Now remember, pi is just a number, so you're going to multiply that in the calculator times 7 times 72. So when you multiply those out, let's see, you're going to get this big number, and I'm not rounding. You only round at the end. So I'm going to have, okay, so I'm not rounding anything. So on your calculator, still leave it as that. The last step is I want arc length to be by itself. It's 360 times arc length. So I'm going to do the opposite operation. So I'm going to be dividing. So this divides out. So now my arc length equals, so right here, whatever you have in the calculator, don't erase it. From there, just divide by 360, and we're going to get 8.796, blah, blah, blah. I go back to what the question's asking me. It's telling me to round to the nearest tenth. So that means it's 1 place after the decimal. So because the hundredths place is 5 or greater, we're going to round up. So my arc length is equal to 8.8, and I'm checking if I have any units. I did. It's centimeters, and that's it. That's your final answer. So that's method 1. What you're doing is you're cross multiplying your little part over the whole circumference, your little degree of the angle over the whole degree of the circle. Notice all you're really doing is taking your circumference times your central angle, and at the end you divide by 360. So with that being said, method 2 is just this formula, if you like this better. And it is more faster. So method 2, you just go straight to the formula, which is arc length equals my circumference times the central angle divided by 360. So this is my circumference, and that's my central angle. So this equation got derived from those proportions. If you're looking for arc length, that's what you're doing. So that means for here, you would do the same thing. Let's say you only wanted to do this method. 2 pi times my radius, which was 7, times the central angle, which was 72, over 360. So it's the same thing. You're still multiplying your circumference times central angle divided by 360. So when you do that, you're going to get the exact same answer. After you round, you're going to get the same thing. Arc length equals 8.8 centimeters. So it's up to you. If you're more of if you like seeing proportions like a visual, you could do that way, or just go right to the equation. Whatever you prefer. So that was arc length. Now we're going to talk about area of a sector. You're going to notice it's very, very similar. Let's go ahead and do the next example. So now we're going to talk about area of a sector. So find the area of the shaded region, round to the nearest tenth. This is a sector. And to go back and talk about what a sector is, back on our notes, right here. It's a region inside a circle bounded by 2 radii of the circle. So there's a radius and another radius, and their intercepted arc, which is right over here. This whole area inside is called the sector, the shaded area. So again, for this one, I'll do method 1 and method 2. You're going to see it's very, very similar to the first one we did. Okay, so to find the area of the sector, so that's what we're going to find, area of sector. So think about a little section, a little area, little section of your circle. This is the area of this little section. So I want to know what the area of the whole circle is. So underneath will be area of circle equals your central angle all over the whole degree of the circle, which is 360 degrees. So if you notice, very similar to the first example. This is the same. It's your angle that you have over the whole degree of a circle. The only thing is now, if I'm dealing with the area of the sector, I need the area of the circle. Meanwhile, here was an arc length, which is part of the whole circumference. So that's the only thing that changes. And now we're going to plug in our values. So we have area of sector over the area of a circle, which is, the formula is pi r squared equals my central angle, rather than theta, 360 degrees. So I have area of sector pi, my radius is given is 11, so I'll have 11 in here. And my central angle is 30, and that's shaded area. And now you can just go ahead and cross multiply. So same style, you have 360 times the area of sector equals, now I'm taking my area of the circle times the central angle. Okay, so we're going to go ahead and multiply this out. So think of order of operations. PEMDAS, you're going to do exponents first. So I'm going to have a pi times, 11 squared, which is 121. So I'm going to have 121 pi times 30. Put that in your calculator. And notice again, the last step is you're going to divide by 360. So at the last step, you're going to divide by 360. So we're going to put all this in the calculator. We're going to do 121 pi times 30 divided by 360. So you're going to get 31.677 blah, blah, blah. I have to round to the nearest tenth. So that means I'm going to stop it one decimal place. Now because this is 5 or greater, that's when you round up. So the area of the sector is going to give you 31.7. I check if I have units. I do. It's inches. And because we're dealing with area now, area 2D, we're squaring our units. Now, so if you notice for method 2, all you would have done is take your area of your circle times your central angle divided by 360 if you want to just get right to it. So method 2 is just a formula. Method 2, it's going to be the area of sector equals pi r squared times the central angle divided by 360 degrees. So this is the area of circle, and that's your central angle. So you would just plug it in and you're going to get the exact same answer. So area of sector, pi times the radius squared, so that was 11 squared times 30 over 360. That's about 30, but you know what I mean. Okay, so same thing. You're going to do the exponents first, then multiply by pi times 30. When you do all that, you are going to get the same answer, which will be 31.7 inches squared. Always round at the end. So you get the exact same answer. Squared multiplied by 360. So same style on both. Okay, so we'll do one more example for area of a sector, and that'll be all for this video, and then we're going to move on to video 2 with the other topics. So now, for example 3, find the area of the shaded sector, leave in terms of pi. Okay, so this way you do method 1 or method 2. I'm just going to do method 2. That's what I prefer. So I'm going to do the area of sector equals the area of the circle times my central angle all over 360 degrees. So this is what I'm looking for. I already have the radius, which is right here at 6. Now we need to know what the central angle is. Now you want to probably say, oh, it's right here. That's my central angle. So let's first look at what angle that is. It didn't tell me, but because it has that square shape, this is a right angle, which means this is 90 degrees. However, that is not the central angle you're using. This is not part of your shaded sector. On the previous one we did, yes, the 30 degrees was in the area that you're looking for. Here, it's not in there. So let's think about it. This is 90. I want to know what is the rest. What is this whole yellow angle going to be? So in a circle, it's 360. And I am taking away that 90 to find out what's the leftover. So I'm subtracting 90. So I'm going to get 270 degrees. So that's the central angle because you need it to be in the shaded area. So watch out for that. And now order of operations, I'm going to go ahead and first do my exponents. I get 36 pi times it by 270, and at the end just divide it by 360. So just divide it at the end. So when you do that, oh, but wait, before you even multiply by pi, it said leave in terms of pi. This means I do not multiply my pi out. That's telling me my final answer should have pi in it because they want an exact answer. So right now, we're not going to even deal with this. We're going to do 36 times 270. And then you're going to divide that by 360. So I get 27 pi. I don't multiply the pi out because I want that in the answer. So the area of the sector, 27 pi units, meters. Because I'm dealing with area, it's going to be squared. So that's if they tell you just leave in terms of pi or they want an exact answer. So now we got area of sector done. So we're going to move on to the next video.